So for today, you can see by my tremendous drawing that this is a fish that has eaten another fish. Would you agree that that has happened in the ocean sometime today? Okay. Would you agree that it's even possible that the little fish had eaten another little fish earlier in the day, and so now it was a fish inside of a fish inside of a fish? I bet you that has happened to the extent that there's a chain of 10. Tiny fish gets eaten by bigger fish, gets eaten by bigger fish, and all in one day. I think that's possible. I really do. Because there's no logical end to it except for the killer whale, which doesn't usually eat their things whole. They're big enough, they're catching big enough things that they kind of tear them up in pieces and eat them. So that kind of breaks down at the end, with the killer whale being the top of the food chain. All right, why are we talking about this? Because I'm trying to make math more interesting. And this function here, f of x, is going to eat another function. In fact, I'm going to keep the color scheme the same. I'm going to say that f of x is going to be the red function. I see you. Glad you're here, but that's really late. All right, so realize if it gets to 10 minutes late, you don't get credit for the class.
Yeah.
Okay. All right, we'll talk more.
I came from a doctor's.
Okay, excellent. Good. Thanks. That's good to know. So f of x is going to be x squared plus 8. Nope, minus 8. Would you agree that you can feed this function, f of x, anything you want, and it won't have any restrictions? You can feed it positive numbers, you can feed it negative numbers, it's going to be fine. Do you agree? Good. That means that this one's domain is all reals. And I've made up until now, I've made you write that with negative infinity to positive infinity, but I'm going to make a change because there's so many times when the answer is negative infinity and positive infinity, we need a shortcut for that. And here's the official math shortcut. You make 2 lines like that and then an R. Anybody want to take a guess at what that stands for? All real numbers. That stands for all real numbers. It's just an R with an extra line. It's like you're doing 2 things and then an R. Okay? That's the symbol for all real numbers. So do you agree I can put all real numbers in this function and it would be fine? Okay, so that's the answer. It's all reals. If a kid had written this, I totally respect that, and it's right. It's just that it takes literally 1, 2, 3, 4, 5, 6 characters instead of one big R. All right, so it's just a shortcut, and I'm okay with that on the test too. As long as that's your answer is negative infinity, positive infinity, you can just say R, big R. Stands for all reals. Okay, now I said that this function was going to eat a smaller function. And that smaller function is this blue function, and we're going to call it g of x. And it's going to be 1 over x. Now let's talk about its domain. The domain of the g function. I'm calling it d sub g. This is just like notation. You don't have to say it that way, but it's a shortcut way to say domain of the g function. Is this one also all reals, or is there a restriction? Restriction. So on this one, we actually have to write. It works from negative infinity until it hits what? What's the one thing it can't be? 0. Union 0 to infinity. Do you agree you got to add a test on something very similar to this? Okay. That was a domain test. You tested on this. But this is more evidence that math really builds on itself, because we start these problems by doing little tiny domain questions. And then we say, now I'd like you to figure out what is f of g of x. And I'd like you to look at that, and I think you'll be able to tell. Which one? 8. Which one? Which one was the predator? The f. It ate the g function. And the g is inside its belly. You know, they look at alligators sometimes after they've missing a missing person, and they'll find usually realistically alligators are not eating a whole person, and that's a really big alligator, but they'll find like a hand. It's gruesome, but it's true. They'll find a part of a human inside the alligator. Does that mean for sure that the alligator killed the person? No. They might have found them dead, they might have died of a drug overdose, and then they ate them later. Or they could have been killed by a human, thrown in the pond, and then the alligator ate it. But either way, sometimes inside of an alligator, if you want to Google this sometime, it's kind of hilarious, all the things they found inside an alligator. All these crazy things. The craziest thing I remember right this second is a license plate. Can you imagine how uncomfortable it would be to eat and swallow and put in your stomach a license plate? But anyway, so the f function has eaten the g function. What does that look like math-wise? Really important to keep the parentheses right on this, okay? So I'm going to start with the f function, which is this one. You don't have to copy the whole thing, just the x squared minus 8. Please copy that down. And if I were you, would copy this problem all the way. This is like your big main example problem for today. Because the one you might want to look back on it. And I know a lot of you are not motivated enough to look back at your notes. Some of you are. I think I've mentioned this. The only person I knew that looked back at their notes every single day for every single class. They got A's in every single class they ever took all the way through college. Okay, so looking back at your notes is powerful. But if you're not going to do that, at least you're activating part of your brain that's better at memory. All right, so x squared minus 8 has to eat something else. I replace the x with a parentheses. You'll see that this parenthesis theme is going to keep coming back. You need the parentheses there. Sometimes you'll get it wrong without the parentheses. Other times they're just nice to have, but they're really important. Always put parentheses there. And then you drop the other function in. Because remember what it ate? It ate a g of x, which is this one. So it goes in there. And that's it. Now you do have to multiply it out. But what's 1 squared really?
1.
Just 1. So 1 over x squared minus 8. And that's the function, and that's it. But now, would you agree, we have a new function that was made up of the two parent functions, we call them. It's a new function. We could call it a new name if we wanted to. We usually don't. We usually just call it f of g of x. But just so you know, if we were in honors, they might have said that now we're going to call that one q of x, or some third name. But I think it's just fine to just say, this is the combo function. Technically, just so you know, the official name for this, these are not functions that's well-ed functions. These are called composition of functions. All right, so this is a composed function. All right, so now I had two domains. I'm going to highlight them. I would if I were you. If I were you, I would highlight your domains. This is one of your domains. This is your other domain. And now we need a third domain. And that is, we've created a new function. And it itself might have some weaknesses. And sometimes they're different than the weaknesses that the parents gave them. But for this one, what is its weakness? What are you not able to feed this one? 0. The one thing you can't feed it is 0. So its domain is just same as the other one. I'm going to use a number line. I personally really like number lines, and I think you know this. I'll accept them as your homework, and I think they're easier. Everything except 0. So I put an empty spot at 0, and then it's shaded like this. So this is the part where it starts to get tricky, so pay attention. You also have to look at the family history of weaknesses. You also have to look back here and say, this child function will have the weaknesses that it has, plus any weaknesses the parents had. But in this case, the only weakness it had was for 0 anyway, so it really didn't matter. Now, how is that? I'm trying to make another, this is like, yesterday I went to the doctor, okay? And one of the things they ask you is family history. So for example, my brother had a colonoscopy done, and they found something in there that wasn't good. He's my brother, and he's older than me. Do you get that there's a chance that there's something in the family, so to speak, where I might have something too? If I have a colonoscopy, they might find something bad in me. So there's family history. You look back and you see, is there any chance that, okay, another one is my dad had 2 heart attacks. Do you get there's a chance then that he gave that to me? And maybe when I'm old, like he was old when he had them, thankfully. Some people, I know a guy who his dad had a heart attack and died when he was like 50, like way younger than me. So he had to really be careful because he knew that could be in his family history, so it might happen to him. So moral of the story is if you have 2 functions that are the parent functions, they pass on any weaknesses. In math, it's simple. They do pass them on. If this has any weakness, which it did, this one here had a weakness for zeros, it passes that on to the kid. But sometimes the kid has different weaknesses too. You know, like maybe the kid ends up with, my sister ended up with lupus. My mom and dad never had lupus, but my sister got lupus. So sometimes it doesn't come from the parents. Sometimes you get your own weaknesses. All right, so I know I'm trying to make it more interesting, but it's true. We look back at family history in the doctor's office, and we do it in math too. Whatever this one has for weaknesses, we got to list that, but we also have to see if there were any weaknesses that came down from the parents. All right, so now I'm going to give you another one. You ready? For this one, I want to just not worry about domains so much. I want to go back and give you a problem from yesterday. And do you remember how to find the vertical asymptote? That's located somewhere. It's either the top or the bottom. And I tried to really pound on which one you didn't care about and which one you did. And then the horizontal asymptote, I tried to give you a dumb way to remember which one's X1, which one's Y. Okay? And I tried to give you the 1,000 method. Do you remember plugging in 1,000? All right. See if you can tell me the vertical and horizontal asymptotes of this. In a moment, I'm going to ask you to compare with the kid sitting next to you and see if you remember how to do verticals and horizontals. Hint, remember, one of these is y equals something, and one of them is x equals something. I'll pause while you give that a chance to marinate. I did teach you yesterday about 24 hours ago. There's almost magical 24-hour forgetting window where if I remind you right now, it's going to stick way better. So, okay, so the verticals come from the bottom. The bottom here is telling me that this thing has a weakness for tens. And if we're talking about domain, we'd say everything except 10 is like safe to feed this function. But if we're talking about vertical asymptotes, we say that there's a weakness at 10. X equals 10 is the vertical asymptote. And I said vertical is like zertical to help you remember where to put them. And the horizontal is like the horizontal. Y equals, and for that, you would put in 1,000. And do you agree that if you had 1,000 and you take away 9, it's still pretty much 1,000? Do you remember these deals where you go like, that doesn't really matter and that doesn't really matter? So it's about 1,000 over about 1,000, and that's about 1. Raise your hand if you had y equals 1. Sweet. A lot of you remembered. Cool. Do you get that that's vertical and horizontal? So you were absent, so I know this. Hey, way to go. That's awesome. All right. So we got verticals and we got horizontals. So could they be more complicated? Of course. Sometimes they're going to be ones you can factor. So let's do one like that. Y equals x squared minus 9x minus 10 over x squared minus 25. That'll factor both on the top and the bottom. And then remember, once it's factored, that's the place to put in the 1,000. Don't put in the 1,000 here. You'll just get confused on what to do with it. Wait till you factor it and stick in the 1,000 then. Vertical asymptotes, horizontal asymptotes. I'll pause for a sec and give that a shot. All right, so here we go with the verticals. Those come from the bottom, and I hope you knew how to factor it, because if you can factor it, you should. And this is x minus 5 and x plus 5. And then on the top, I hope you knew how to factor that. Noah, you got the top? You got that factored?
Yeah.
Okay, what'd you get?
-10.
Negative 10. positive 1. Double checking it, and that makes negative 10, and plus 1 makes negative 9. Perfect, nice job. All right, now, which one do I care about for the verticals? The bottom. And so the bottom here is telling me two things. X equals 5 as a vertical, and X equals negative 5. Now, I know some of you are going to be like, I thought you said to say not equal to. That's for domain. For domain, you're saying, what can you feed this function? And then you want to say not 5 and not negative 5. So that's for domain. So if they had asked what's the domain of this function, I would have said x is not 5 and x is not negative 5. And that would have been easier to just make a number line and say can't be negative 5 and can't be 5, but it can be everything else. So that's an example of how you do domain. But back to this. Horizontal asymptotes, I said to wait till now to put in what? 1,000. If you guys have already done this, you probably were able to say, you know what? Subtracting 5 from 1,000 doesn't really do anything. Or adding 5 doesn't really do anything. It's because we're kind of rounding here. And so really this is like 1,000 times 1,000 over 1,000 times 1,000. Would you agree they can all cancel? But that leaves behind something. 1. Very good. So that's the answer. Y equals 1. Notice it was a horizontal, so I knew it was a y equals horizontal. Okay? How many of you actually had the asymptotes correct? Good. Now take 2 seconds and sketch them. You need to see that they look like them. There's 2 verticals. They're dotted lines. And there's 1 horizontal. It's a dotted line. So that's what they look like. If you were in honors right this second, we would be finding a whole bunch of points. And I don't think it's that hard, but you would then have to make an XY chart and pick some numbers, and I'd put it into the factored form here, and you'd put in like, let's put in 3, and then you see what you get. And then you'd find a bunch of points, and it would look kind of like this when it's done, like gets closer and closer to the asymptotes. So maybe like that. And then maybe like that. And they are a pain in the butt. They take like 20 minutes to do. All we really have to have you know is where the asymptotes are. So that's all we do here. All right. So how about one more of those kind where you have to figure out the domain based on the weaknesses of the parent functions. In this case, it's going to be p of x. I want to make sure you get that it isn't always f and it isn't always g. P of x is x squared minus 4. And m of x is 1 over x. My advice to you is right away figure out the domain of p and the domain of m. Remember that if you find one that's all real numbers, you can put a big R instead of writing negative or parentheses, negative infinity, comma, positive infinity, parentheses. The big R is just way faster, and it means all reals, so it's good. Do you know in the old days they actually cast lots, as in like dice, and they would even use it to make really big decisions? Like, geez, we really don't know if we should do this or that. And they would roll the dice and see what it said. So, here we go. See who gets called upon, the dice of destiny. We're choosing Sabins. Domain of P.
For P, it's all real, so it's the same thing.
All reals, good. Or you could say negative infinity, positive infinity. And next good is Claudia. The dice have chosen you. This one. What's the domain of that function?
The domain of that one is negative infinity to 0.
Yup, so you're saying basically everything except 0, right? Finish that.
And then 0 to infinity.
Yep. My U looks kind of like a V. I'm going to fix it. Cool. Now we've got the two parents, and kind of like the theme I showed you that picture earlier. They're having a child function. This is going to be P. Let me make sure I do this right. I want the M function to eat the P function. Now my analogies are getting all mixed up. But P or M is eating P. You could read that as M of P of X. Okay. So look at the two functions. The M function is eating the P function. So start by writing the M function. And I said, make sure that you have a parenthesis where it used to have the X. Parentheses are a big deal. They're coming up in a minute, they're going to be even a bigger deal because people will forget the parentheses and they'll get it wrong. In this case, you might have been able to be okay. Now, I've started with the M function and it's going to eat the P. That then goes in there and I have x squared minus 4 in there. Now, to figure out the domain of this new thing, you look at its domain and you look at its parents' domains all together. Remember, it's like you might have a condition that your parents don't have. Like this one, he can't, there's two things that you can't feed this function. Even though it came from this, which had all reals, now that it's on the bottom, now that it's divided, this thing is saying I can't have 2 and negative 2. It would kill this function. Do you get that wasn't in this domain and it wasn't in that domain? You got to find this one's weaknesses, which is, I like number lines, so I'm going to make a number line. And honestly, this is what I would do if I were you on the test. I would make a number line. There was like 3 kids that didn't make number lines, and like 2 of the 3 got all the problems wrong. Okay, so I strongly recommend you make a number line. And I know on the last test you didn't have to because you could write it this way, but trust me, the number line's better. And then you can write the interval after the number line. All right, so what are the 2 things it can't be? Negative 2 and 2. You know, this could be factored, and you'd easily see it's x plus 2 and x minus 2, and those are the 2 weaknesses. So it's everything but 2 and negative 2. And if you left that as your final answer, it's going to be wrong because you didn't look at the parent weaknesses. It'd be like if I'm a doctor and I just asked you what hurt, and you say, oh, I got a really sore leg because I was playing soccer and blah, blah, blah. And they didn't ask you any family history and find out that, oh my gosh, you have something running in the family where that sore leg might actually be a sign that you have something far worse. They got to do family history. So you got to do family history. Do you get this one had a weakness for zeros? So you got to put that in your final answer. You got to say, and it can't be 0. Now this isn't that much different than what you did on your test. Do you remember on the test you had to combine all the answers into one number line at the end? Do you remember that? It was like the last 2 questions of the test were like that. You put it all together on one number line. And there's your final answer. And I know it's like, but this says you can't put in 0, but I don't see any problem. It's because it was a weakness of the original functions. And they have to be included. So there's your final answer. And if you had to write that in intervals, it would take 1, 2, 3, 4 intervals to do it. Negative infinity to negative 2 would be how you'd start, and then you'd go negative 2 to 0, and then 0 to 2, and then 2 to infinity. My gosh, I hate having to do all of that, so I'm okay with just doing a big number line for now. On the test, it'll probably say interval. Yeah, you'll have to do it on the test, but if you've got the number line, everybody in here knows how to take the number line and turn it into intervals. So just start with the number line, and maybe that'll be good enough. Okay, I have one last one, and this one, it's just important for you to do one completely yourself. So you start with 2 functions. Right away you do their domains. Then you make the one function eat the other function, and you figure out its weaknesses. But then you have to include all the weaknesses on one number line. So there's like 5 steps. All right, you signed up for Precalc. Here we go. F of x is x squared minus 36. G of x is 1 over x plus 32. First thing I'd do is figure out their domains right away. And remember, if these are the parent functions, they could pass it down to the children. Next up, you're going to figure out what g of f of x is, make the one function eat the other function, and then figure out its domain, which in turn relies on the parents. All right, I'm going to pause for a sec, see if you can handle biggest, baddest, hardest kind. Okay, g of f of x. So I'm going to start by going and doing what I said I would do first, which is I would do the domains first. Domain of f was all reals. How many of you had that on your paper? Awesome. Next one, domain of g is everything except it can't be negative 32. So I'm going to put a negative 32 on a number line. I like to do it this way. That's how I do it. Now, this one function eats the other. I start with the predator function, 1 over x plus 32. I replace the x with a parentheses. And then I put in the other function. It's eating this one. So that goes here. X squared minus 36. Now, if you didn't notice this, it's really important. You got to put that all together and get a final answer of 1 over, what's negative 36 and positive 32 make? It makes minus 4, yes. Nice. Now, do you see that this one has a weakness for 2's? 2 and negative 2? So you might think, okay, so the domain of this new function is that it can't be negative 2 and it can't be 2. And you'd be sort of right. But what else do you have to put in there? Yes, remember how this one had a weakness for negative 32? So that has to go in there also. Just like our last test, you end with a big number line. Yeah, if they say you have to do intervals, I think you could do the intervals from there. It wouldn't be that hard. Negative 32, or sorry, negative infinity to negative 32, 32 to negative 2, negative 2 to 2, 2 to infinity. All right. Yes?
How do you know, like, g of x is, like, eating f of x?
Because whatever's on the outside, that's the predator one. This one's on the inside. I like to think of it as that one's inside the stomach of the other one. Okay? So this is the one that's eating the other one. The one on the outside is always the one that eats the other one. Okay? So if you list them, you know, if I said P of M of X, M is the one that just got eaten. You'd start with this one and make it eat the M. Okay? All right. Okay. How many of you made it to that answer without my help? Like you got that one? Not many. How many of you didn't notice the whole x squared minus 4 thing? Okay, good. Do you see where that came from? Because the negative 36 and the positive 32 came together and made negative 4? Now that you see that, it's not that hard, is it? Okay. You probably just didn't think about putting it all together and getting this. So, common misconceptions, people think, oh, it's just the two parent domains. No, it's not. If it was just the two parent domains, it would have just been everything except 32, or negative 32. But it's also whatever the new function's domain is, and you put them all together in one number line. And I want to, if anybody, like math teachers watching this at home, I want to tell you this to just kind of cover my butt. There is a much more complicated way you have to do these if you have what's called artificially restricted domains, which again, in honors, they would say, oh, by the way, x has to be greater than or equal to 6. And that's the domain for this function, even though you thought it was something else. We don't do artificially restricted domains in this class, and therefore the way we're doing our domains is going to work fine. There's a really complicated formula then that you have to use if you're in honors or in AP to figure out that new domain. And you can't just look at the three. You have to do yeah, it's nightmarish. Yes?
So the child's domain is just the intersection of the parents' domains?
Plus its own. So do you get that this new, look at this new domain. All of a sudden, twos are a thing. Do you get how twos aren't allowed? But the parent didn't have a weakness for twos. So it's not just the two-parent domains. It's two-parent domains and whatever the new function has for weaknesses. So it's all three. It's the intersection of the two-parent domains plus the intersection of that with the domains that, or the weaknesses that this new function has. So all three of them together. So zooming out, here is the one-parent domain. Didn't even really matter because it was allowing everything. Here was the other parent domain, which would have just been negative 32 is not allowed. Here was the third domain. X could not equal 2 and x could not equal negative 2. And we had to put all three of those together on a number line for our final answer. Okay, the other part is just adding functions, which is so easy. So your homework is going to ask you to like take f of x is x squared plus 3. And g of x is like 2x. And they're going to say, what happens if you take f of x plus g of x? It's so easy. You just like take that plus that, and that's it. You just add them together. 2x, or sorry, x squared plus 3 plus the 2x. That's it. The only thing you have to do is like simplify it. Do you get normally, you put these in order like x squared plus 2x plus 3. I probably wouldn't even mark it wrong on a test if you forgot to rearrange them in order, but you should rearrange them in order. Okay, so adding functions, just add them. It's so easy. It's the domain part that we spend all hour on because that's the hard part. I wanted to focus on that. But now I'll start your homework with you so you really make sure you understand it. There is problem 10, the very last one is a skip. I'm just making your life a little better by skipping that last one. There's not that many problems in this because those domains are tricky. So it's pretty short, but you can skip the last one. Jack, would you read me number 1, please? Yep. And I know it's got like handwriting in there. That's not the key. That's like asking the question. So they give the two functions and then they hand wrote in what they want you to do. Okay, so what are the two functions for number 1?
F of x equals 2x minus 1 and g of x equals x squared.
And then what did they want me to actually do? Was it f of g of x or was it g of f of x? You start on the outside.
F plus g.
F plus g of x. Okay. Then we just have to add the two functions. So that one plus that one. It's as easy as you would think. It's just 2x minus 1 plus x squared. Technically, there's parentheses here, but they won't matter on this one. But they will matter when you drop in your two functions in a subtract problem. So let's do that next. Would you please read me what's the next one, Jack?
F minus g.
F minus g of x. So here's my two functions. My f function minus my g function. Notice the parentheses. Okay, so now my f function, 2x minus 1. My g function, x squared. And you're like, Mr. Server, those parentheses didn't really matter. Do you get if there had been like a plus 3, you'd have to distribute the negative? That's what's going to happen on the test. Tons of you are going to forget that you have to put that negative on both things because you got to put them in parentheses. In this case, I know it wouldn't have actually had to have the parentheses and it would have been fine. Negative x squared plus 2x minus 1. That's just me putting it in the right order. And that's it. That's adding the two functions. Does it want the domains of all of these? 2? Jack? Like, is it asking for and the domains? Oh, okay. So then we should go back and do, what's the domain of f of x? This guy, domain of f. What's the domain for that? Remember, domain means what can you safely feed that function? All reals. What's the domain for the g function? All reals. There's no restrictions on that. So then what's the domain for this one? Well, it's the two parents, which we already have as all reals, plus does this have any restrictions? No. So it's just all put together, so it's all reals. The new function here is right here. Is there any restrictions on that? No, I could put in any number I want. There's no square roots that'll fail, and there's no denominators that'll turn into 0, so it's all reals. Looking back at the parents, this is just kind of a dumb one because they're all real everywhere. So then the domain's just all reals. Then, did they have you end with f of g of x or just f times g? F times g is just take the two functions, I put a parenthesis around them like this, and I drop them in, 2x minus 1 and x squared, and then you do have to actually multiply that out. Just finish it by actually multiplying it out, because you know that the parentheses mean multiply, right? So 2x times the x squared makes 2x to the third minus x squared. And does that have any restrictions? Nope, all reals. All right, let's move on to the second question. Bodie, would you read us number 2?
F of x equals square root of x.
Ooh, that's gonna have restrictions. Keep going.
G of x equals x squared plus 2.
Okay, so the f function, the domain of that is x is, do you remember how this works? There's a symbol, I know it has to be positive, but what's the math symbol for that? Greater or equal to 0, very good. And the domain of g? All real, big R. It's a lot faster than negative infinity to positive infinity and writing all that out. But now, remember, one of the parents has a weakness. That's going to follow through to all of the children functions. They all have that same weakness then. So when we do f plus g, you're going to just take the f function plus the g function. Parentheses in would be so smart, I'm telling you, because that's the one that gets people on the test all the time, is when you do minus and kids forget the parenthesis. In this case, I know, technically you didn't need the parentheses. If you wanted to know what order this in, x squared would be first, square root of x would be next, and 2 would be last. For those of you that are math nerds or want to be, that's x to the 1/2 power. And that's why it goes after x squared. X squared is a bigger power. This is technically x to the 1/2 power. That's what square root means, is 1/2 power. All right. Does that have any weaknesses? Oh, yes, it does. X has to be greater than or equal to 0. And then you look back at the parent weaknesses. Oh, it got its weakness from here. That makes sense. It could have its own weaknesses, but this one was a hereditary weakness. And there's your final answer. That's the domain of that. Okay, so that was the two functions being added. Now, the subtract one. The one that people get wrong the most, because they forget these parentheses. And then when you drop in your two functions, I put the parentheses there for you. Will you remember to do that on the test? Otherwise, you'll forget to distribute the negative, and that happens all the time. They say a good teacher tries to tell kids where the common mistakes are. Trying. It's whether or not you're listening. Those parentheses are huge. Okay, and the rest of the time is yours.